Mercedes-Benz automobiles incorporate many features engineered to protect their occupants in the event of an accident. But perhaps the best accident protection is provided by enhancing an automobile's ability to handle so that it can safely respond to your command to avoid a dangerous situation. The anti-lock brake system, ABS, sets new standards for performance and safety by allowing you to maintain steering control, even during a panic stop on a slippery surface. This program will provide you with the theory, operation, and diagnosis of the Mercedes-Benz anti-lock brake system, the state-of-the-art in vehicle control. The foundations of control are the 4 contact patches where the tires touch the road. They are the automobile's only link with the road surface. It is through them that you direct the stopping and steering forces. When you turn the steering wheel, the front wheels will obviously turn in the direction you want to go. But the automobile will only go in that direction if the tires communicate with the road by continuing to roll. This is because only a rolling tire can exert steering force. A locked wheel and tire no longer transmit steering force. It just scuffs along the road. With locked wheels, the automobile won't go where you want it to, no matter how the steering wheel is turned. Remember, only a rolling wheel can communicate your steering commands to the road. But what causes a wheel to lock? Simply stated, wheels will lock when you push the brake pedal too hard. How hard is too hard? It all depends on road conditions. The same easy push on the pedal that slows the automobile on dry pavement may lock the wheels and cause an accident if you're on a slick road. This is because slippery road surfaces only give the tire a small amount of traction. In order for your steering and braking commands to be transmitted through the tire's contact patch, you need traction from the road. While it greatly improves control, ABS cannot change the laws of physics. That is, an icy surface will still be just as slippery. But by keeping the wheel rolling, ABS lets the tire grip and effectively maximizes whatever amount of traction is available from the road. As long as you push the brake pedal, ABS will allow only enough pressure to be metered through to the brake caliper at each wheel to slow it down without reaching the point of lockup. By braking the wheels just to the point before lockup, the steering and braking forces are maintained while the automobile slows down. Incidentally, the screeching noise you hear when a wheel locks comes from the rubber as it's ripped from the tire and left on the road as a skid mark. And although the purpose of ABS is to ensure that steering control is maintained under all braking conditions, it can also help reduce the longer stopping distance that would normally occur on a dry, hard-surfaced road. This is because in this case, the loss of grip from a locked wheel reduces the braking force. Now that we're familiar with the basic theory, let's look at the components ABS adds to the standard brake system. The front wheel speed sensors, the differential speed sensor, the electronic control unit with overvoltage protection relay, the hydraulic control unit, and a system monitoring light in the instrument cluster. The front wheel speed sensor is installed in the steering knuckle, and a toothed wheel is part of the front hub. A shielded cable is used to screen out interference from other electrical components. A sensor and toothed wheel in the differential measures the average speed of both rear wheels. Each sensor has a magnetic core with a coil of wire wrapped around it. As you may recall from basic electrical theory, whenever the magnetic field around a wire changes, a voltage will be induced. Each tooth is a magnetic conductor, and as it passes the sensor, it changes the magnetic field around the sensor. This change in the magnetic field induces voltage in the coil, which will change frequency according to wheel speed. Thus, by monitoring the frequency of the voltage signal, it's possible to tell how fast a wheel is turning. We'll refer to this as the wheel's rotational speed. The electronic control unit, the brain of the system, receives the frequency signal from the wheel sensors and is responsible for monitoring the rotational speed of the wheels. The ECU has a built-in reference value in its logic circuit. It compares the deceleration rate of the wheel with this reference value. The ECU can thus tell if a wheel slows down too suddenly and is about to lock up. If a sensor informs the ECU this is about to happen, the ECU will immediately send instructions to reduce brake fluid pressure at the caliper of the affected wheel to allow it to keep rolling. Until this wheel is out of danger of lockup, pressure will be limited no matter how hard you step on the brake pedal. Thus, ABS keeps braking force within an ideal range by controlling the rotational speed of the wheels. The system automatically regulates brake fluid pressure to keep the wheels from locking when you apply the brakes too hard. Now let's take a closer look at the component that receives instructions from the ECU, the hydraulic control unit. The hydraulic control unit is in line between the master cylinder and the calipers. It contains 3 electrically operated valves. One for the hydraulic circuit to the left front wheel, one for the hydraulic circuit to the right front wheel, and one valve for the hydraulic circuit to the 2 rear wheels. Each of these valves operate independently. The valve is a simple arrangement consisting of an electric coil and sliding piston. If we want the brake system to work as it normally does without ABS, no current is applied and the valve stays in the open position. Now, anytime the driver steps on the brake pedal, hydraulic pressure from the master cylinder passes unchanged straight through the hydraulic control unit to the brake caliper. It is as if ABS does not exist. This will be the valve position for the great majority of driving conditions. If, because of road conditions, the wheel should begin to lock up, the ECU would apply half current to the respective hydraulic control unit valve and move it to the pressure holding position. Now, no matter how hard you step on the brake pedal, it will not be possible to apply any more pressure to the caliper. Lockup is prevented and steering control is retained. If road conditions are such that even with pressure holding the wheel is still in danger of lockup, full current is applied to the valve and it's moved to the pressure reduction position, uncovering a return channel. Brake fluid pressure at the caliper is now bled off and returned to the master cylinder by an electric pump. The rotational speed of this wheel is now increased. When this happens, you will feel the brake fluid pressure return as a rapid pulsation in the brake pedal. Therefore, it can be said that ABS is really a brake pressure modification system. It can only operate when the driver steps on the brake pedal. It can never generate any braking pressure on its own. Also, it can never increase pressure above that exerted by the driver. The safety circuit monitors the following: the wiring harness, power supply relay, and ECU, the speed sensors, and the hydraulic control unit with its 2 relays and 3 pressure regulating valves. A warning light in the instrument cluster will come on if the safety circuit spots a problem. When this happens, ABS will be switched off automatically. The brakes will now function like a conventional system without ABS. The safety circuit includes a built-in test cycle, which is initiated each time the engine is started. The test cycle begins when the wheel speed sensors indicate a speed above 3 miles per hour. If you have your foot on the brake pedal during the test cycle, a pulse will be felt, which is part of the normal functioning of the system. The system also monitors the voltage supplied to it. ABS will be switched off if voltage drops below approximately 10.5 volts. The warning lamp in the instrument cluster will then come on. If voltage should come back up while driving, the light will be switched off. Note that this is the only instance where the light will go off while driving. In all other situations where the system spots a fault, the ABS light will come on and stay on. Therefore, if the light comes on intermittently while driving, a voltage supply or ground problem should be suspected. Poor electrical contacts, insufficient alternator output, or a defective overvoltage protection relay may be suspected. Power is supplied directly to the ABS via an overvoltage protection relay. The relay is activated by circuit 15, which is hot with the ignition switch in the run position. Before proceeding with diagnosis, here are a few important points regarding the electrical circuit. A replaceable fuse protects the ECU from excessive voltage peaks in the electrical system. 2 relays are located under the cover of the hydraulic control unit. One supplies power to the return pump, and one supplies power to the electrically operated valves that regulate brake pressure from the master cylinder to the brake calipers. To perform detailed diagnosis, the test procedure that accompanies this program can be used. The ABS test adapter and a multimeter are required. The function test will check the ABS power supply, sensor inputs to the electronic control unit, and the valves in the hydraulic control unit. Before performing the function test, first switch off the ignition and all electric consumers. Disconnect the 35-pin connector from the ABS electronic control unit and plug the test adapter into the wiring harness. To illustrate how the test program is used, let's say you have now reached that part of the function test where you're checking the solenoid valves in the hydraulic control unit. To test the pressure holding position, the key is switched on and the tester set to the position corresponding to the circuit to be tested. The vehicle must be raised so that its wheels can be rotated. You would now push the P equals button on the tester. This directs the control valve in the HCU to go to the pressure holding position. Remember, in the pressure holding position, pressure from the master cylinder is blocked off to prevent wheel lockup. Therefore, even though the brake pedal is depressed, the wheel will turn freely because hydraulic pressure cannot reach the caliper. The other tests are performed in a similar manner. Following the procedures noted in the book will help you diagnose and correct any difficulties that may occur in the system. Additional information on the ABS system is found in Service Microfiche Group 42, the Diagnostic Directory, and the Electrical Troubleshooting Manual. This completes anti-lock brake system, operation and diagnosis, an Education for Excellence service training program.